I'm Anil Kumar. Welcome to my YouTube channel. Let me thank all the students, the followers, and the subscribers to watch my videos, post brilliant remarks, and ask questions. Now, asking questions is some of the things which we should always do. You can always send a request on my email address given here. In this video, I'm going to discuss at length solution of set of questions posted by one of our student followers, Nicole Castro. Thank you, Nicole, for sending the request. I'll at length explain how do we solve radical related questions. So 5 questions from your request are in this particular video. We are going to discuss them one by one. For all other followers, you can look at these questions, try to answer them, and then check with my solution. So the questions here are question number 1, 5 square root 2 minus 3 square root 8. We need to simplify them, right? So 4 expressions to simplify: square root 2x minus square root 8x cubed plus 3, square root 18x, square root 16x square y minus square root xy plus 9xy cubed in square root. And question number 4 is 8x plus y cubed minus 32x plus y whole cube. And both of them are within the radical sign. Then we have a simple equation to solve, which is 3 minus square root x minus 4 equals to 0. So let's try to understand the strategy of solving such questions. Let's begin with the very first one, which is 5 square root 2 minus 3 square root 8. How do we do that? Now, important thing here is to look for like terms, correct? So what are like terms? When we are talking about radicals, if anything in the radical is exactly same, then they are called the like terms. So we could actually write this expression as 5 square root 2. This is a mixed radical, right? Minus 3. So 8 could be written as product of 4 and 2. Do you see that? So the idea here is to write 8 as product of its factors, and we should look for factors which are perfect squares, right? So 4 is a perfect square, right? What I mean to say here is that we could actually write this as 5 square root 2 minus 3 and square root of 4. 4 is kind of 2 square, correct? 2 square. So square root of 2 square will be 2. So we can take this outside. That's the whole idea. What I'm trying to say here is that we could actually write this as 5 square root 2 minus 3 times 2 square root 2. Now, you notice that square root 2 and square root 2 are similar radicals. So we call them as like terms. Do you understand the concept now? So we could now write this expression as square root 2 is common, right? So we have 5 square root 2 minus 3 times 2 is 6, 6 square root 2. I hope you have understood this. Now, since we have two like terms where square root 2 are exactly same, we could actually do 5 minus 6. And 5 minus 6, as you know, is minus 1. And therefore, we get minus square root 2 as our solution. Is that clear to you? Now, we discussed this at length so that you understand the concept. This concept is going to be followed in all the questions you are referring to, correct? So, you have understood all this. I would like you to pause the video now and answer the next question. The idea here is to write something in the radical, simplify so that we have like terms. Once you have the like terms, we can actually simplify. So the next one here, we have square root of 2x within the radical. It cannot be simplified. However, 8x cubed. Look here, 8 could be written as 4 times 2, where 4 is a perfect square. X cubed could be thought about as x squared times x, right? So x squared. So we have another perfect square here, plus. So 3 within square root. 18. 18 could be written as 6 times 3, 18 times 1, but also 9 times 2. Now 9 times 2 is helpful since 9 is a perfect square. You get the idea, right? So that is why I was saying write the number as product of factors, and preferably one of them should be a perfect square. Only then you can simplify, otherwise you cannot, right? So what we have here is square root 2x as the first term. In the next term, we can actually see that there are two perfect squares here, 4 and x squared. And in the last term, there is a perfect square, 9. They can be taken outside, so we have 2x outside, and within the square root, we have square root 2x. Perfect. And in this particular case, we have 3 times 3, since 9 square root is 3. And within the square root, we have 2x. Now clearly, you can see that 2x is common. Perfect. They are all like terms. So what do we have? Outside, we can take 1 minus 2x plus 3 times 3 is 9. Correct? And that 2x is a common factor. So we kind of took all those coefficients of our like radicals and combine them. That is how we are going to do it. So I hope the steps are absolutely clear. Now I really like these questions because gradually we are learning the process of how do we simplify the radicals. Now question number 3 and 4 are very similar, right? Except for now we are talking more about x and y terms. I'd like you to actually pause the video now and answer these, correct? Now tell me, 16 is what? 4 square, right? So think like this. This is square root of 4 square, right? And then we already have x square y. So we could actually take out 4 and x from this, right? So 4 square is 4, and then x square is x. And within the radical, we have y, correct? Okay, so that is what we get here. Now in the second one, what I think there is a typing error in this case. It was probably, okay, if it is like this, let it be so. Okay. Now, in the other two terms, square root xy, we cannot do much, correct? So I'm writing them as such. Square root xy, both the steps. Is that clear to you? Now, the last term here, we have 9 here. 9 and y cube. Y cube can be written as y square y, correct? It could be written as y square y. And therefore, we could actually write this as square root of 9 is 3, right? Square root of y square will be y, and within the bracket we have x times y. You get the idea. So the third term is 3y square root of xy. Now in this case, the last two terms, the second and third, they are like terms, and therefore they can be combined. So we can actually combine the last two, but not the first one. And therefore our answer will be 4x square root of y minus. Now if you combine these, then what do you get? Well, you can write this as 3y minus 1, kind of rearrange it, right? So let me write this as plus, and then 3y minus 1, and within square root xy. Is that clear to you? So that is how we could do it. The last question amongst this series of simplifying, we have x plus y whole cube. Now that is a common term, right? So as we have seen in the previous examples, if there is a cube, it is like square times the term. Perfect. Okay, let us do the last one, right? Here you can see that we have x plus y whole cube as a common factor, right? Do you see that? So look, you could consider like this. When we have x plus y whole cube, it could be thought of as x plus y whole square times x plus y. Is that clear to you, right? When you put it under a radical sign, you could actually write this as what? You could write this as x plus y times square root of x plus y. Is that clear to you? Correct? That means we do have this factor x plus y times square root of x plus y as a common factor for both of them. So we could take away x plus y outside. Perfect. And now You also know that square root of 32 could be written as square root of 16 times 2, which is 4 square root 2, right? And you already know that square root of 8 is square root of 4 times 2, which is 2 square root 2, correct? Now from these, you can easily simplify the given expression, correct? So let's use this and write down our answer. So I hope you have understood the concept, right? So now I've erased this out. I'd like you to write down a simplified form of the given expression, which should be what? Well, which should be that we have 2, let me write 2 outside, 2 x plus y, right? Within radical, we have 2x plus y. I hope you've understood. And the second term will be 2 times 16, 16 square root is 4, so 4x plus y, right? Within radical, we have 2x plus y. And now clearly, you can write down the answer from here. So I hope this step is now clear to you. Now clearly, what do we have common here? We could do 2 minus 4, which is minus 2, right? This is a like term. This is a like term. And so we can do 2 minus 4, which is minus 2, and write down our answer, which should be minus 2 x plus y. And within this radical, we have 2x plus y. Clear? So that becomes the solution for this particular question. I hope it is absolutely clear. Right, now let us take the equation. Well, what I did here was that I kind of gave you the solutions in the typed form. So you can once again look into the steps, which are very common steps to write down the solution, right? So in the very first question, which was 5 square root 2 minus 3 square root 8, I'll prefer to write 8 as 3 times 2 square root 2. And 3 times 2 is 6. And so we do get like terms with 5 minus 6, and minus square root 2 will be our answer. Correct. In the second question, we had shown all the calculations, and here is what it is. Perfect. The third question solution is right there before you. And the last question solution is also there for you, right? In the test, normally, you could follow these steps and write down the solution as we have shown here. Now let's look into the last question, which is how do we solve radical related equations? So the equation given to us is 3 minus square root of x minus 4 equals to 0. Whenever you are given an equation, you should also look into restrictions, right? We know that within the radical, x minus 4 should be greater than equal to 0, and that means that x has to be greater than equal to 4. So be careful. The answer has to be greater than 4, right? So that is the restriction. Sometimes we'll write x is greater than equal to 4 as a restriction. Well, another thing is, whatever answer you get, you need to check your solution. Sometimes we have extraneous rules. Be careful. Look into the link which provides you in details more examples based on radicals. Now here are simple steps to follow to solve such a radical equation, right, with square roots. So the equation given to us is 3 minus square root x minus 4 equals to 0. Isolate the radical. That is my first step. So we could take this on the right side. This becomes square root of x minus 4 equals to 3. Now we can square both sides. Remember, at this step, when you square both sides, there is possibility of error. Can you tell me why? And that is what we have to check our solution. Is that clear to you? Why? Because let us say we have minus 7. If you square this, you get what? You get plus 49, correct? So, but if you do square root of 49, what do you get? You get 7. And these two things are not equal, right? They are not equal. And that is the reason why there is a possibility of error. A very important step. But anyway, in our case, we square and we find it is x minus 4 equals to 9. Now it's a simple linear equation. Taking 4 on the right side, adding to 9, we get 13 as our answer. right? So the idea here is to check your solution. Substitute 13 for x in the equation and check. So we do get 3 minus square root of 9, which is 3 minus 3 equals to 0. So that says that the answer is absolutely correct. Perfect. And therefore, we have a solution which is x equals to 13. Perfect. So that becomes the solution, right? So x equals to 13 is the solution. But I hope with this you have understood simple steps to simplify the radicals and solve for an equation. I hope that makes sense. Feel free to write your comments, share your views, and keep posting your questions. I'm there to provide you with the best and simplest solutions. Thanks for your time and all the best.